Assalamu alaikum, and today I will be continuing again with the course. And I had done this part in Julia programming language. Now I need to continue with this. So now the I'm going to do this with NumPy, and then I'm going to do it with this with Torch, and let's see how this goes. So I need to open VS Code. Projects, AI from scratch, and AI engineering, and CD phases and code dot. And so I'm going to first try this. Basically, this I should shorten this, and I'm going to create another file here named numpy numpy test. What should I even name it? The hardest question in programming, what to name the thing. NumPy example.py. So import NumPy as np. I'm going to do source. I think it's another. Okay. A is equal to np dot array. It's going to aggregate three d type float. It's a float type array. Then b is equal to np dot array. Can just copy this. And 456. 456. It's a float type, data type, and now print f a plus b is equal to a plus b. Okay, and print f a dot b is equal to a dot b and p dot a comma b. So this is the function in NumPy for dot products. And what else is there? There is printf. This is the magnitude p dot lin and norm a up to 4 floating points. It's not printf. This is not C. This is Python. So that is np dev docs. So in the documentation, I'm going to read about lin and where lin alg. I think this is going to be in the NumPy. I'm going to enable this docs and okay, enable and enable devdocs.io. Basically, devdocs.io is a way to look at the documentation offline. So I'm doing that. Just a second, I need to download the actual documentation, I guess. Stop showing this message or whatever now. Offline data and install. Both of these are now installed. Now I can search at NumPy. What was the thing? NumPy lin alg. So linear algebra norm NumPy norm. Why is it so hard to find it? Lin alg dot norm matrix of vector norm. This function is able to return This function is able to return one of a different matrix's norm or one of an infinite number of vector norms described below. So it takes an array-like uh, thing as a parameter, then it can be must be one dimension or two dimension unless ORD is none. If both x's are none, then two norm x-ray will return. I don't know what that means, but let's continue. Okay, so it takes an array and normalizes it essentially. So, so what is this going to do? np dot arrange, np dot reshape to 3 3 norm a, normalize a, and np dot infinite. What is it doing exactly? Returns an ND array. I could just pay, like, I could just do it to see what it does. Let's continue with this. And now the cosine. A cosine similarity, I know the cosine similarity is equal to the A dot B divided by A magnitude and B magnitude. A magnitude and B magnitude, essentially. Then let's do this. So print f, I'm going to do this on my own. Print f, so cosine similarity. I think I missed an I here or something. Whatever. Cosine similarity is equal to the A dot B. So NP dot A comma B. I put D here. That was a mistake. Python set project environment. Actually, I should source Python set project environment browse back. Go back. Go back a bit. Come on. VNV. I'm pretty sure it's there. Why isn't it going back? Dot VNV and bin and activate. Activate dot sh, I believe. Activate dot bat dot nu is one of this one. Okay, now this activated. So A and B. So A dot B divided by the um, A magnitude and B magnitude. I think they did it differently. They're doing something else, I think. So what is it that they are doing? Or they actually no. Cosine similarity. This is something else. NP dot A dot B. They're normalizing it. I don't get it. Why they are normalizing it. Norm. Normalization means to divide by the magnitude and make it a unit vector, I'm pretty sure. Then why are they doing that? Why are they doing that? I suppose I don't get it. What's the difference between linear algebra norm and this? So normalize. I might as well write this. I don't understand why they're normalizing it. I just don't get it. They're normalizing the vector, so they are converted it into the unit vector of A and the unit vector of B. They are normalizing it, meaning they're dividing the vector by its magnitude to get that. But I don't get why. But I guess I'll see the result and then make a conclusion. For dot linear algebra norm, so value norm A times np dot linear algebra norm B, and it's up to 4 floating point values. Okay, now what else is there? This W is equal to np dot random dot n random dimension. It returns a sample or samples from the standard normal distribution. I don't know. This conveys a function for use supporting code. Ta-da-da. Return C also. It generates a random number, okay, 2 and 3. Multiply by zero point 0.1. X is equal to p dot array 1.0, 0 0.5, and minus 0.3. And prints f wx is equal to w at x. This is a new operator in Python that multiplies stuff. CDML fundamentals, Python 3, numpy example.py. This is the cosine similarity. I mean, they are pretty similar in a sense. If I make this extremely similar, what's going to happen? Are none the norm x ravel will be returned norm of a matrix or vectors. If I'm not wrong, normalization is just conversion. What is normalization of a vector? It's just dividing the vector by its magnitude to get the unit vector, essentially. So find the magnitude and divide by each component. I understand that, but why is it dividing by its um by uh by the normal? Why? Why is it doing that? I want to understand that. So I know that A dot B is equal to A magnitude and B magnitude. B magnitude. I wonder if I change this just to that, would that also work? And cos theta. Where am I? What did I just do? I'm in Julia. What? Cos theta. So I'm going to cos theta. Then this becomes A dot B divided by A magnitude and B magnitude. I know this um A magnitude and B magnitude. I know that the magnitude is just the square root of the squares of every um, component of the vector. I understand that, but they are doing it a bit differently. They are normalizing it, multiplying it, and then dividing it by that. Why is that? I just don't understand that. Because technically speaking, let me try it actually. If I delete this, if I delete inside this, and I just do np dot magnitude, is there a function for that? mag, numpy magnitude, numpy dot lin lg. The determinant is the it's not the magnitude. I don't think so. Still, where is it? Like cross, outer, diagonal, multi-dot, dot. So, vector norm, matrix power, matrix rank. Where is the magnitude? Magnitude is as simple as it's just the square root of the square of every single component. So, what is another name for magnitude? Magnitude, length, um, compute the determinant of an array. Does a one-dimensional matrix have a determinant? Um, does a 1D matrix have a determinant? It's just 5, so that does not have it. Where is the function? Since I don't want to just search it with an AI, how do I get this matrix multiply? Does it even have it? I mean, its entire library it would have it, I'm pretty sure. Conditions, inverse, normal, cross, outer solve, back dot. Okay, I guess also numpy, um, array, vector, um, magnitude. This gives me the magnitude. I thought this was normalizing. I guess there's another formula for normalizing. Um, Euclidean distance. And I understand this, but it's just 2 points. It's subtracting this point to get the distance and taking the Pythagoras theorem for that. Yes, it's the Pythagoras theorem. It's getting that. Okay, for 2 dimensions. Then let me just see by it. So it does calculate, but it has a weird name. I thought it would just be magnitude. I thought it would just be a magnitude, but it's not. Why? So this is the actual thing. Where is it? Dot norm. There's a difference between norm able is able to return one of a. How about numpy lin alg norm? Is this different from that documentation? No, it's not really. The result is strictly speaking not a mathematical norm, but is maybe useful. Uh, I can't believe I'm just stuck on this, or whatever. Okay, so this is so this was the normalization. It's just the magnitude. But why is it called such a weird name? Like norm. Norm is normalized. Why is it called that? Why is the function in NumPy called ln_norm when it's not normalizing, it's calculating the magnitude to a length of the word norm in mathematics simply means a function that assigns a strictly positive length to a vector. A specific geometric length of a vector, usually the Euclidean, that measures the size of a vector. The magnitude vector by its norm creates a unit vector. The norm, a mathematical function, denotes the measures the size of a vector. So it gives me the size of the vector, and the magnitude, this is a specific geometric length of a vector. Usually the Euclidean norm. I see. So magnitude is between 2 points, I guess, and okay, so the terms are different. Okay, there was someone who actually asked this question, funny enough. Four-base norm. So if I don't give it an order, it gives a four-base norm. What is magnitude of a matrix? Now this is given the actual magnitude. This is such a deep rabbit hole. What is this? Okay, this is the Forbes norm. It's just the sum. It's the sum of square of all of them and just the squares. Okay, now I understand. This is the magnitude. So I could just do that. I spent all that time, but I learned something that is great. Linear algebra dot norm A times. So this is just doing the Euclidean norm or Forbes norm, which is a square root of square of all of the numbers in the matrix. Norm B. Okay, that is great. I learned something. So Wiki. So also there's a problem in these docs that they don't render this properly. Hmm. Dev docs. I am not rendering the mathematical formula properly. Um, okay, whatever. I don't want to go there, but let's continue. Project. This is done now. I have to do this with PyTorch. So PyTorch dot example dot py. So import torch. Actually, I need to what wiki numpy. What is numpy? Numpy. The fundamental package for scientific computing. So it has pretty much all the built-in functions that I would need. So for example, I learned about the to determine the rank of a matrix, the Gauss-Jordan elimination, and what else did I learn? Normalization, dot product, Gram-Schmidt's process, etc. Yeah, orthonormality. All of those are built in this. Great. So this arrange, it creates 15, 1, 2, 3, 4, 4, 4, and 4. That's 12, 3 by 5. Okay. Oh, it's 5. What am I doing? Okay, let's continue. I understand. And let's do this. X is equal to torch dot rand n 3 requires grade. True. Y is equal to torch dot tensor 1.0, 0.0, and 0.0. Now I have to look at this again. Dev docs. I need to search about torch. Need to enable it, install it, and now I have PyTorch documentation. PyTorch uh, torch.random returns a tensor filled with random numbers from a normal distribution with mean 0 and variance of 1. So I know what a tensor. A tensor is just an n-dimensional vector or matrix. Um, Greater than 3 dimensions call it tensor. I'm pretty sure. Wikipedia tensor is an that describe multi-linear relationship. Tensor map different this. Present a potentially multi-dimensional array just as a vector and dimensional space represents by one-dimensional array an n component with respect to a given base, any tensor with respect to a base. So order 1 tensor, order 2 tensor, 3 tensor, and order 4 tensor. So it's just an n-dimensional matrix. Okay, so this creates for me a three-dimensional wave with the required gradients true. What is that? Generator optional, D-type, layout. If autograde should record operations on the return tensor. If the autogradient should record operations on the return tensor. I don't know what that means. Okay, let's continue. So lar, similarity equal to torch dot xy. Similarity dot actually similarity print f is equal to x dot data, y is equal to y dot data. Print f dot product is equal to similarity dot item. What is similarity? Difference between similarity and similarity? Print similarity, print similarity dot backward. Computes the gradient of a current vector. What does that mean? I'm gonna print this out. What does this do? So Python, PyTorch. What? No module name. UV pip install torch. It's installed. All right, I need to source it. So when bin activate. So now I can do this. What does this do? It kind of did nothing. I don't understand. What does that do? Uh, dot backward. Requires specifying a gradient. It should be a tensor matching types and shape that represents the gradient of differentiated functions. Function accumulates gradients and the leaves you might need to zero. I don't understand. I don't get it. I don't get it at all. So torch dot product torch dot backward. What does torch dot backward do? Derivatives gradients of a tensor with respect to all leaf tensor that were used to create. It gets the derivatives of the tensor. Okay. I mean, in the AI course, they haven't even given an explanation for this. I have to search this up myself. I mean, it's okay. I guess they cannot put everything in there. Yes, I don't understand. I'll put this for later. So this is a tensor. It performs an x and y. Um, what if I do this? What's going to happen? Gonna crash? It's going to crash. So this creates a gradient or something on the random generator one, and I do similarity backward, creates the derivatives of the gradient or something. Let's the gradients of a tensor with respect to all, like model weights and inputs. Um, I don't understand. We'll get you dot, then calculate the dl by dx over your code. L is equal to 2x is calculated by PyTorch firstly, then the dl divided by dx. Um, I don't get it, but let's continue. I don't get it entirely. I'm confused. I get that it's the dot product is the similarity, and then it does it backwards, and I don't see a difference. Don't see a difference at all in that. So how is this going to work? So this is dot product similarity dot I gives me the. If I don't do this, what's the difference? So that is the dot product divided by the change in it. That's the derivative of the dot product. Uh, is the similarity dot is the backward in tense torch just derivative of dot product. Walaikum salam. Continuing with the course. I was right over here on this tensor and vector with autodiff. So autodiff, I learned about the gradient that it was just a derivative of the dot product. The derivative of the dot product. And that is just equal to y, as this just says right over here. I try to imagine it, and if I am not wrong, as x increases, as the value of x increases, x or y increases, obviously the dot product will increase because dot product is just a scalar quantity. And if one vector increases, the other will also increase as well. So today, in this entire module, I have learned about dot product, attention scores and transformers, cosine similarity in RAG, matrix multiply, every neural network, every linear transformation has matrix multiplication. Linear independent feature selection avoid multicollinearity. So it tells me if the vectors are linearly independent and they're not in the same line, because if the vectors are in a straight line, they are collinear. Then there's the rank of the system determine if a system is solvable. This determines if a vector system of vectors is solvable. That is low rank adaptation. I should search this again. What is low rank? I should check if my mic is working fine. Yes, I think it's working fine. No. Um, so no, this is not the singer. Lora. This is the matrix. Um, what is it that I should search properly? This is determined for low rank adaptation. I should read more about this essentially. LoRa machine learning, low rank adaptation is a parameter efficient fine-tuning technique for large language model and the deep neural network introduced in 2021 by researchers at Microsoft. LoRa enables adaptation of pre-trained model to specific tasks while requiring significantly fewer computational resources and trainable parameters than traditional fine model tuning. The development, okay, whatever purpose, and by decomposing updated meters into low rank representation rather than updating all the parameters in the neural network during fine tuning. LoRa freezes, oops, Or freezes the pre-trained model weights and injects trainable rank decomposition matrices into each layer of the transformer architecture. This approach is grounded in linear algebra and explores the hypothesis that weight updates during fine-tuning have a low intrinsic rank, meaning the change can be effectively represented with fewer parameters than the full weight matrix. Okay, when applied to GPT LoRa to the reduced trainable parameter by 10,000 from 10,000 times, meaning 1.5 billion to roughly 8 million, and GPU requirements to 3 or 1.2 terabytes to 350 gigabytes. So I think I should learn about this more. Um, LoRa machine learning, low rank adaptation, and I should also open VS Code over here. AI from scratch, and okay, this is a good thing. Low rank technique used to. Okay, here it is. Surface the original weights and parameters of models as they are, and then on top of the original model, it adds a lightweight addition called low-rank matrix, which is then applied to the new inputs to get results specific to the context. The low-rank matrix adjusts for the weights of the original model so that outputs match the desired use case. LoRa leverages the concept of lower-rank matrices to make the model training process extremely efficient and fast. Traditionally, fine-tuning element requires adjusting entire model. LoRa focuses on modifying a smaller subset of parameters, low-rank matrices, to reduce the um, computation and memory overhead. So this is the pre-trained weights, and this is what it's get. These are the pre-trained weights. Lore is built on understand that large inherently process a matrices are an important part of how machine learning models do not work. Low-rank matrices smaller have many fewer values than the larger or higher-rank matrices. They do not take up much memory, require fewer steps to add or multiply to get this makes them faster for our computers to process. A high-rank matrix can be decomposed into two low-rank matrices. A 4 by 4 matrix can be decomposed into a 4 by 1 and 1 by 4 matrix. Two low-ranking matrices. So how exactly? How exactly does this work? So 4 by 1, the number of columns of the first one should be equal to the number of rows of the second. If I multiply these, would I get this matrix? Calculate line. So minus 2 minus 176. 4 by 1. So this is minus 2 minus 176. Minus 2 uh, minus 176. And then on the second of 4 1 3 minus 3. 4 1 1 3 minus 3. When I multiply both of these, I get the same matrix. Okay, so how would this work exactly? Minus 2 multiplied by 4, minus 2 multiplied by 1, minus 2 multiplied by 3, minus 2 multiplied by minus 3. I understand now. I understand how this works. What is the exactly is the process for breaking it down? What exactly is the process? Matrix to the frozen original adds lower to floors of the long gradient descent during fine-tuning without modifying the weights of the base. Okay, how does breaking of a matrix with a high rank to low rank work? Work low rank approximation, singular value decomposition. The first process of approximating a given way by a matrix lower matrix. More precise, it is a minimization problem in which cost function measures the fit between a given matrix data and an approximating matrix optimization variable subject to a constraint. The problem is used for mathematical modeling and data compression. So how does this work exactly? I know the Forbes norm. This is the matrix normalization, which is just the magnitude if it is a one-dimensional matrix. So it is Forbes norm is the square root and the um, yes, sum of every single one, sum of square of every single value in the matrix. So that is the Forbes norm. A singular value decomposition of T, which is sum of this. Oh, Accordion-Marinsky theorem. Okay, this is a bit advanced for me, I think. But whatever, I'm here to learn anyway. And then what do I need to do? Alternative projections algorithm. What? I don't get it. This problem was originally solved by Gram-Schmidt. Okay, I'll just continue. I get the gist of it. So Laura is used to make the already trained model make the parameters of it smaller, I suppose. Linear regression projecting onto columns of PCA. So Wikipedia regression. Oh, actually projection. Projection is a linear transformation from a vector space to an endomorphism is a homomorphism. Okay, such that P dot P is equal to P. That is, whenever P is applied twice to any vector, it gives the same result. If it were applied to P is idempotent. If leaves its image unchanged. Okay, let's commits. It shows up in numerical solvers and eigenvalue computation. An orthonormal basis stable numerical computation of Whitening transform. It fine-tunes large language models by decomposing weight updates into a low-ranking matrices. So instead of updating a 40 this big matrix of 16 million, or updates two matrices of 1496. Okay. Multiply 16 and 16 multiply the rank 16 command or answers the weight updates live in a 16 subsystem. Assumes the weight updates live lives in 16-dimensional subspace for the 1490 dimension of this linear algebra doing real work. Implement this. I need to get the angle between two vectors. Okay, let's do this. So vector, and I need to calculate the angle between two vectors. So def angle between other, the self and other. It will take toward itself and the other. So I know the algorithm that B is equal to magnitude of A and magnitude of B cos theta. So in a sense, theta is equal to A dot B divided by A B and in cos inverse of this. So all I have to do is take the dot product. So the dot is equal to self dot dot other and then magnitude of A and magnitude of B. Um, and then I need to, this is called the divisor. The divisor is equal to A self dot magnitude multiplied by other dot magnitude other dot magnitude. And I need to return the cos math arc cosine measure radians of the other. So arc of dot divided by divisor. This should work. Now let me see. These two vectors are entirely perpendicular to each other, so in a sense it should return angle of 0. Print a angle between the see the phase Python and vector.py. It did not print anything. Why? Why did it not print anything? What? Oh, no, this is not correct. The name is something else, I'm pretty sure. So A, return the arc cosine. It is in radians, okay, but still, it should be pi by. Oh, actually, that is correct. So, so I think I should do something like math dot a cos. Return the arc cosine of x in radian. This is basically inverse. Does it take an extra parameter? Between 0 and pi, it basically returns the value. Is there a way to convert it into convert x from radians to degrees? So I could do this math dot degrees. Uh, this should work. 90. Excellent. Great. Now this is working. Now let's move on to the next challenge. Create a 2D scaling matrix that doubles the x-coordinate and triples the y-coordinate, then apply it to the vector this. Okay. 0, 1 angle between vectors. Now I'm doing the other one. This is a matrix problem, so it should be done right over here. So I'm gonna comment this out, and now I need a 2D scaling matrix that doubles the x coordinate and y coordinate. Y the x and triples the y coordinate. coordinate, then apply it to one. So let me make a vector. So vector A is equal to vector of 1, 1. And now I need two-dimensional matrix. Need a two-dimensional matrix. A scaling matrix equal to matrix. Um, so I need to double the x coordinate. So double the x coordinate and um, double the x coordinate and triple the y coordinate. The matrix is a transformation, so 0, 0, something like this. So what's it going to do is going to double that and triple that, if I'm not mistaken. Then I'm going to print um, matrix dot multiply is there a value. So A scaling matrix, Python matrix is a. Let's continue with the next challenge. The next challenge is about your 5-word like vector dimension. Find the most similar word like vectors dimension 15. Okay, so I need to do this. Given 5 random word, give me 5 random word like vector. What? Okay, my internet is gone. Alright, yes, I'll generate them from it. Give me. So I will give it this problem. It will represent the word in a 50-dimensional vector. A random word like vectors. Just give me one. Oh, I guess I could generate this. So 5 and then numpy. So default. I guess I should just look at how the AI np to the random different and vectors is equal np dot random dot rand and 550. So I should look about the dev dogs random dot random and the float. Okay, to create it from the 5 vectors, so I need to find which of those are the most similar. So length of vectors. Current is equal to, it will start from 1 and not from 0. So current is batteries about this die. My battery is about to be a goner. Alright. Current is equal to, I guess I should make alright. Alright, so I created random vectors when I'm taking vectors. Actually, I should create my own vectors. I'll do this problem later because I'm a bit tired now. I need to check if I need to check if the Gram-Schmidt produces vectors that are truly orthogonal. So I have linear independence right over here. I need to check if it truly produces a output vectors that are truly independent of each other. But first, let me run this to see what is happening. It is producing a zero of all. So what do I need to see? Dot product is zero, and the magnitude of every single one of these vectors is 1. V1 is equal to the V1 dot magnitude. Okay. Okay. Why is this? What is this? What is this? Magnitude of V2. So it should be basis I and U. So this should be, yes, good. Good, good, good. Create a 3 by 3 matrix with rank to verify that the rank method, then we're using the rank method, then explained with geometric object the columns span. If it's a rank 2 matrix, it will obviously two of the vectors are linear in a straight line, meaning they are linearly dependent. That means that the vectors are linearly dependent. They are in the same line, so they would make a plane, not a cube. While if they are linear independent, they would make a cube. So let me create a three-dimensional matrix. I need to create a 3 by 3 matrix. Matrix is equal to matrix 1, 2, 3, and so it's a rank 2 matrix. So this will be 2, 2, and 2, 4, 6. I basically did this and multiplied this by 2, so they are in the same line, and I can just do something like something weird here, like 5 by 5, 6, 6, and print uh, is linearly independent matrix. Module is not subscriptable. What does that mean? Alright, I should call this. Oh, from matrix import matrix. Matrix has no length. What? Alright, I need to create 3 vectors and I need to turn them into a verify using the rank method. I have not created a rank method. I could just create one rank. This takes in a matrix. Matrix. It takes in a vector, or it could just be a matrix. Okay, it takes in vectors. It takes in vectors. I'm just gonna copy all of this and put it right over here. All it does is return the rank. That is it. Now I need to create a bunch of vectors. So vector. All right. Now what? Not a rank. This should be a vector. Rank takes position of one. What am I doing wrong? Length vectors. Oh. It takes a list of vectors, and I don't get what am I doing. What am I doing wrong over here? Let me do something like 1, 2, and 4. 2, 4, and 8, 9, 99, and 100 or something. No, I should do 101. It's basically something different. This is giving me 2. So if it's a rank 3 matrix, does a rank 2 matrix make a plane? The number of independent at the column to make has a two-dimensional space, meaning a plane. Okay, so if it's rank 2, it spans a plane, so it is a plane. Okay, what is the last one? Project this vector onto this. What does the results represent geometrically? So I need to project A onto B. I will do that over here. Okay, now I need to project. Projection is basically A dot B divided by A mag times B mag. No, 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 no. Actually, it's A dot B is equal to A magnitude B magnitude cos theta. So I want to find A onto B or B onto it. It's the same thing. So I can just do. Did I make a function for this? I don't remember. So print 1 dot v2 divided by v2 dot v2. The sorry, magnitude of v2 doesn't really matter because it is commutative. A dot b is equal to b dot a, b dot it, so it would be the same thing. So Python vector 3.4. What does that represent? So when I project a vector onto the other, it creates a straight line. So it basically it takes two vectors and turns them into a single line. And that's it. Alright, that was a lot. I cannot go away without doing this problem. Find the two most similar using the uh, cosine or whatever that means. So I need 5 vectors of dimension 50. What? Alright. So 0 to 50 dimension matrix. So vectors is equal to vector of I want to create a vector 50 times. So vector 50 times for I in range of 50. So let me do this. This will create a 50 vector to Python vector.py. What does that do? Yes, it created 50 vectors. Now I want to create 50 5 random word-like vectors. No, actually I want to create 5 of these vectors and they will have 50 units. Maths maths dot random numpy dot random. I want to create a random number. How to I could use a seed. Returns random dot random. So numpy so np dot random dot random. All right. I want to find the most similar one of these. So for I in range of length of vectors. Going to start from 1 because current is equal to the um, dot 0 I minus 1 dot with a cosine similarity with the other vectors dot I get the mm, with the previous one I want to find the max similarity is equal to dot 0 dot cosine similarity vectors dot 1 vectors dot 1. So if the current is greater than the max similarity, then max similarity is equal to the current. And I already max out of bounds by Jugaad. This works. Does it should add and git commit completed one module. Not completed, finished one module and git push. Thank you so much for watching this. And if you stayed with me to the very end, thank you. And goodbye, Allah Hafiz. I will see you next time, inshallah.